All right, here we go, X-intercepts. We're going to start by defining what they are. If you have an XY coordinate system and you have a polynomial, any place that the polynomial crosses the x-axis is an x-intercept. We talked about this yesterday, didn't we? Okay, excellent. So now the question is, when you have a polynomial, how many x-intercepts can there be? Well, the max number of x-intercepts equals the degree of the polynomial. The number of x-intercepts may be less than the degree. Odd degree polynomials must have at least one x-intercept even degree polynomials may have 0 x-intercepts. Lots of rules. I'm going to draw a really weird polynomial here as an example. Y equals x to the third plus dot, dot, dot. The reason I'm drawing this is a third degree polynomial, and we don't know what the rest of the terms are. We only know the first term. So here's what happens. This number determines the max number of x-intercepts and then these terms determine the actual number of x-intercepts. So let's look at the first scenario. If we have y equals x to the third and some other terms, the max number of x-intercepts is 3. Now just looking at this is positive, so what is the right-hand end behavior? It's up, right? So the right hand is going to be up. The degree is odd, so the left hand is going to be down. And if we had the maximum number of intercepts, the polynomial could look something like that, where we would have 1, 2, 3 x-intercepts. But it's possible that we don't have 3. These terms here could cause us to have less. We could have 2 x-intercepts, depending on these other terms. Or we could have 1 x-intercept, depending on these other terms. So those are all the possibilities. Now if this polynomial is odd, which means we have to have one tail and up and one tail down, is it possible for there to be 0 intercepts? No, because it goes infinitely up and infinitely down. It has to cross the x-axis somewhere. Hence, this odd degree rule. Okay. Now, what if we had a polynomial that was y equals x squared plus some other terms? What are the possibilities? Well, the max number would be 2 x-intercepts. Now, this beginning term is positive, so the right hand is up. The degree is even, so the left hand is up. The max possible intercepts is 2. So it could look like that, depending on what the rest of the terms are. Or there could be 1 x-intercept, or there could be 0 x-intercepts. May I move this off the screen, or does anybody still need it? Okay. While we're waiting here, get your calculator out and get it turned on. Go to y equals, clear your equations and turn off your plots. All right, we'll move that there. Okay, so what we're going to do next is we are going to talk about relative minimums and maximums, and we are going to determine the Y-intercept from standard form. And we're going to start learning to do this by, on our calculator, graphing the following equation: y equals negative 0.3x cubed plus 4x plus 2. So if you turn on your calculator and you go to y equals, you can enter the equation and then make sure that your plots are all not highlighted. Make sure they're turned off. When you have this set up, reset the window of your calculator by pressing Zoom 6 or Zoom Standard, and you should get a nice graph that looks like that. And what we're going to do is draw a sketch of this graph without any units on the coordinate system. Is everybody with me so far? All right, well, let's eliminate this word relative and just talk about what it means to be a minimum or a maximum. A minimum means the smallest possible number, and a maximum means the largest possible number. But if you look at this polynomial, this thing goes down forever, so it doesn't really have a minimum, and it goes up forever, so it doesn't really have a maximum. It does, however, have these turning points right there and right there. And if you were to look in, say, the area between these two dashed lines that I've drawn, so I've drawn a couple dashed lines. I'm going to call those fences or borders. And I'm going to ignore everything on the outside of the borders. And if you look between the borders, can you find a minimum? Yeah, it occurs at the turning point. That is called a relative minimum, because relative to the area between the fences, that's the minimum. And if you were to draw some fences on either side of this other turning point, well, there's a relative maximum right there. Okay? All right, so relative minimums and maximums occur at the turning points and there is a relative max and there is a relative min. Now what I would like to do right now is show you how to find the coordinates of those points. And to do that, we need our calculator. And here's the process we're going to use. With our calculator, we are going to set up fences and find the min or the max between those fences. Okay? So if you have this picture on your screen, I want you to find the trace button, and right above the trace button you'll see calculate. So do second trace to get to the calculate menu. Do you see in here how there's a minimum and a maximum? Yeah, right. So let's find the minimum first. So go to number 3, minimum, and press enter. Now you'll notice down here it says left bound. And what this means is we have to tell the calculator where our left boundary is or where our left fence is. And the way that you do that is you arrow sideways until the cursor, which is that flashing star, is on the left side of the minimum. And then you press enter, and you should see there's either a little vertical line to make the fence or the boundary, or there's a little arrow up here. And then the calculator is going to ask you for a right boundary, and so now you move the cursor to the right side of the minimum, and you press enter, and you should see the other fence, or the other boundary, indicated by the vertical line or those little arrows. The last question your calculator asks is guess. And so what you have to do is you have to move the cursor near the relative min and press enter. And your calculator will find that point, which for us looks like it's approximately negative 2.11, comma, negative 3.62. Having done that, do you think you can find this relative max? Second, calculate maximum, left boundary, right boundary, guess, approximately 2.11, 7.62. Anybody need help? Did it go okay? No? Alright, yes, go ahead. Alright, we can figure that out real quick. So I am curious about this Y-intercept right there. That is the Y-intercept. I would like you to be able to find the Y-intercept by looking at the equation. Now, let me ask you a question. when you are on the y-intercept, what is the x value? 0. So at x equals 0, y equals, what happens if you plug x0 into this equation? Well, that goes to 0, that goes to 0, and what's left? 2. The y-intercept is always the constant term in the polynomial. It always works like that. All right, we're going to stop here.